Welcome everyone. I am C. Sujay, presenting on behalf of our team Dr. R. Anita, Shivam Mano Shukla, and Sanjay Kumar S. Today we are presenting our work on Secure AI Meeting Assistant. This sits at the intersection of edge computing and AI, and I hope by the end of this presentation you will see why we believe this is a timely and practical solution. Next slide. Let me start with a scenario. We have all been in meetings where important decisions were made, action items were assigned, and then completely lost in the chaos afterward. Existing solutions try to fix this using cloud based tools, but they introduce latency, privacy risks, and require constant internet connectivity. Our system is designed. We have built an secure AI meeting assistant that runs entirely on the user's local device. It combines live speech recognition, a locally running large language model, and an intelligent agent system that works in real time, generating meeting summaries, identifying action items, sending emails automatically, and even performing web searches, all without a single byte leaving your machine. Next slide. Now, let me frame the problem more precisely. Modern meetings generate enormous volumes of information. Manual documentation is unreliable. People miss decisions, forget action items, and summaries are often incomplete. Cloud based assistants address part of this, but they bring their own baggage: data privacy concerns, subscription costs, dependency on external servers, and network latency. So, our major goal was clear: design a self hosted, secure AI meeting assistant that delivers real time meeting intelligence with zero cloud dependency. Our minor goals included achieving end to end data privacy using open source models, implementing real time transcription and 5W1H format summary generation, integrating extracted tasks directly into PM and CRM tools like GitHub and Kanban, building an intuitive front end dashboard, and ensuring reliable performance on standard local desktop hardware.
The foundational concept driving our work is edge computing with artificial intelligence, a paradigm where data is processed close to its source on the device itself rather than being sent to a remote server. This gives us six critical advantages listed as data sovereignty and privacy through local processing, ultra low latency for real time transcription, operational autonomy by eliminating cloud dependency, cost effectiveness by removing expensive subscriptions, local first processing for transcription, summarization, and extraction, and reliability through open source AI model. We implemented this as a desktop application, a practical, deployable tool built for real workplace environments. Our work is grounded in 8 key references from 2024 to 2025, spanning Edge AI, LLM based meeting systems, and speech recognition. Firstly, in this paper, a fully online embedded end-to-end voice assistant was built on edge hardware. The key observation is that offline ASR can achieve near cloud level accuracy with under 1 second latency, confirming that real-time edge transcription is practically feasible. Next in this paper, an LLM powered meeting recap system was designed and evaluated. The observation is that LLMs reliably generate structured summaries and action items, significantly reducing cognitive load compared to manual note taking. In this paper by Chen et al., a large scale multimodal testing dataset was introduced and benchmarked using Whisper and Llama. The observation is that ASR quality directly impacts summary coherence, validating our choice of Whisper for transcription. In this paper, the design of AI agents for more inclusive meetings was explored. The observation is that a well-structured, intuitive AUI is critical for user trust and adoption of artificial intelligence generated outputs. In this paper by Nanashkar et al., a comprehensive survey of AI-powered meeting assistants was conducted. The observation is that maintaining meeting continuity and structured record keeping remain the primary unsolved challenges. In this paper by Suresh Manik et al., A multimodal AI system combining speech summarization and RAG was presented. The observation is that the cloud hosted models introduce the exact privacy and cost concerns of our local edge solution directly addresses. In this paper, a systematic review of transformer based ASR model was conducted. The observation is that optimizing ASR for energy efficiency on edge devices remains an open research gap, precisely what our system targets. At last, in this paper by D. Leo et al., a real-time speech-to-text prototype for edge environment was developed. The observation is that a fully local WebRTC-based pipeline can achieve sub-second latency without a word array below 5%, validating our edge-native architecture. Building this system wasn't without challenges, and I want to be transparent about them. First, hardware compatibility. Ensuring Llama 3 and Whisper run reliably across diverse CPU and GPU configurations is non-trivial. Second, achieving ultra-low latency transcription on local resource-limited hardware. Third, managing the LLM context window across extremely long meeting transcripts without losing coherence. Fourth, maintaining the functionality of our external agent uplink using Puppeteer Extra to join Zoom or Google Meet while bypassing bot detection, which constantly evolves. Fifth, by implementing local AAS 256 encryption for sensitive data without relying on cloud security services. And finally, packaging our entire heterogeneous tech stack, Python, Node.js, and Olama into a single cross-platform desktop executable using Electron. Over to Sujay.
So the system requirements and modules. Our tech stack, what we call the sovereign stack, includes Olama to host Llama 3 locally, Python for Whisper ASR, and Node.js for the backend and Electron wrapper. Our three main primary module groups are the input and live transcription module, which captures audio via the Web Audio API, streams it through socket.io to WASC, and optionally using Puppeteer Extra to join virtual meetings silently. The core intelligent module, our brain, which uses Llama 3 with master prompting for intent detection, 5W1S summary generation, and automated action item extraction, and the workflow and data management modules, which handle local SQLite 3 storage, automated email dispatch, GitHub issue creation, and the Kanban analytics dashboard. We also implemented a Redis buffer engine for fault tolerant streaming and a pub or sub manager for low latency inter service communication. Next slide. Let me walk through you through our four section architecture. Section 1 is the edge layer, the client side consisting of the user's device, microphone, and the web dashboard frontend. Section 2 is the core OS layer, which acts as a hub. It handles the WebSocket real-time gateway and Express API gateway, receiving raw audio, managing real-time communication, and routing data to the appropriate modules. Section 3 is where the intelligent life lives. The live transcription pipeline using WASC streaming ASR paired with a transcription buffer and agentic AI brain powered by Llama 3 via Olama. The agent orchestrator interprets parsed responses and triggers tool invocations. Beneath this sits our data persistent layer, encrypted local storage using SQLite 3 and a secret vault. Section 4 contains our agentic capabilities, the external meeting agent, web search tools, email tools via Node Mailer, a text to speech engine, and GitHub integration for task management. So everything flows locally, no cloud, no external API calls for core function. So now Sanjay Kumar will look into the demo of the secure AI meeting assistant. Mm.
Here you can see the system in action. The login screen uses dual authentication, password plus a time-limited OTP sent to the user's email, ensuring secure access. And I'm filling the OTP now for verification. Now we have gone to the dashboard. The main dashboard lets users start and stop recording, generate the minutes of meeting with one click, manage meeting links, and view real-time analytics, including audio chunks, process partial transcript counts, caption latency, and system stability. The live transcription panel shows the real-time draft and final transcript alongside speaker diarization. And as you can see, I'm speaking a passage here, and the live transcript draft is showing like this. And finally, the final transcript is processed and will be shown below. As you can see, the the person has done with the speech, and the final transcript is processed, and then the transcripts are proceeding for process into the LLM. As of now, the session is end, and once the session ends, the system automatically generates a structured minutes of meeting. As we are stopping the recording, the minutes of meeting is generated, and in the meanwhile, the search results is also shown where a word can be used in typed in a search bar, and the search result is also looked after. We are using DuckDuckGo search model. By using them, we are using the search engine, using them as a search engine. And also we have integrated GitHub, and also and through GitHub we are integrating the workflow and raising an issue. And finally, we get the minutes of meeting in document in 5W1H format with a full action items table, ready to download or send by email. And on the right, you can see our integrated AI search triggered automatically during the meeting to fetch real-time context for topics discussed. And as you can see, the minutes of meeting can be sent through email also. Okay. To summarize, we have built a fully local, privacy first, real time meeting intelligence system that requires no cloud connectivity for its core functions. It transcribes, summarizes, extract tasks, send email, integrates with GitHub, and displays everything through an intuitive dashboard, all running on standard desktop hardware. We believe this addresses a genuine gap in the current landscape and offers a practical path toward truly sovereign AI assisted secure workflows. Thank you.